Good evening, everyone. Welcome to 114th video lecture on misconceptions in physics. My name is Ratankar Rao. I teach physics in an international school, and my passion is to teach physics and to solve problems, a variety of problems, and to know about what kind of concepts usually students make mistakes and help them to clarify it. Okay, so let us begin with today's lecture. Let me share my screen. Okay, we have been working on something called as comparison problems. Comparison problems are a set of problems which are very important in any kind of examination. And so far, we have been doing only on distances. So when we say comparing distances, okay, so there are different types of problems which we had been looking into. So the first problem which we started was about comparing the distances which were in the same direction. Two balls of different masses have been dropped, and as a result of it, and they were dropped maybe 1 second or 2 seconds later on consecutively. And what were they? How do you compare the distances? That's what we did, first one. And then we also looked at, okay, if you want to compare, instead of distances, if you want to compare velocities and accelerations, then how does the result vary? That's what we looked at. And the third problem was based on comparing the height of a fall, wherein what we did was we took a object, we dropped it, and it upon reaching a given height, its velocity was v, and if what should be the height of the particle if the velocity has to get doubled? So this question, most of them make a mistake thinking that when the velocity is doubling, the height should also double, which is incorrect. So this was being proved over here. And then yesterday we did one problem on, okay, if two objects are being thrown in opposite directions, then what can happen? Usually the answer that I get here is that they will meet at the middle. Okay, but that is incorrect. That's what has been shown. And it is seen that, okay, how to work it out. And we got a different answer over here. So please look into this problem, okay, correctly to understand. So why do we get a different answer? Until unless you do not understand this particular problem, MCP4, okay, you will not be able to appreciate this problem, which is just a special case of what we have done in the previous problem. Okay. Now, this was not asked by anybody. In fact, this is a problem which I have coined by myself. Let me do this. Okay, so once again, the same problem. Only difference is what is being highlighted in the red color here. A stone is projected from the top of a tower, 300 meters height. My pen is not writing. Just a moment. Not able to see. Okay, it's here. Okay, so I have a tower, and from the top of a tower of 300 meters height, so you are throwing a stone here, and it's allowed to fall. So you are dropping here, and from the base of the tower, you are throwing it once again here in such a way. So in the previous problem, if you look at it, the same question was asked, but the only thing is it had a velocity. You are throwing up with a velocity of 100 meters per second. Now here, you are not going to throw up with a velocity of 100 meters per second, but instead it says with a kinetic energy. So you are throwing this one with a kinetic energy of mv square, which is equal to the potential energy of the first stone, which is equal to mgh. Potential energy of the first stone is mgh. Okay. Find the ratio of the distances. Where do they meet? Okay. So this was a question. This was not done by any student. I thought, okay, so why or how do we get this? Okay, if I have a question like this, how do we go with it? That's what we thought. So finally, I started working on this. Okay, so towards it, let us approach the same problem. Find the ratio of the distance, which means what? The first object, that is the first ball, when it is being thrown, let us say, okay, it will fall at a distance here. It will fall at a distance h1 here. And this would have gone upwards with a h2 over here. And as a result of this, you need to find out, they both meet at some point. See, I have written it in the middle. They may meet at some point. I just want to find out what is h1 by h2. That's what we need to do. Now, how do we do this? Is the question. So we do it like this. So first is, what is the velocity of throw? So there I had said velocity of throw is 100 meters per second. So here I have not given that value. I have given it by an expression saying that it is being thrown with a kinetic energy equal to the potential energy of the first stone. Okay, that's what is being given. So I can now write v square. I can just cancel this m from here, and thus I can get v square equal to 2gh, or v is equal to square root of 2gh. That's what I can say. Okay. Now what do we need? We need to find h1. How do I find the value of h1? Now what is the initial velocity here? U is equal to 0 over here. And then when it comes here, it has some velocity over v over here. Okay. And then we need the value of h1. So what did we do in the previous problem? In the previous problem, if you see, this distance is x, this distance is h minus x, and then we use x equal to ut plus half at square. Let me use the same formula. Okay. I don't want to get deviated. Let me use the same formula. So therefore, where is it? Okay. So therefore, now I will call this as x here. I will call this as x, and this one would be h minus x. So h1 by h2 is nothing but x by h minus x. Now let us solve this. Now what is x? Previously what we have done is x is equal to ut plus half at square we have used. And I have assumed that this is my x-axis, this is my downward y-axis, which is negative, and thus I can now write minus x is equal to 0 minus half gt square. Okay, and thus I have got this negative and negative goes away, and thus you get t square is equal to 2x divided by g. 2x divided by g. I just retain it as such. I'll retain it as such. Then what's the next step? Now this distance h minus x, or maybe I'll do one thing. I did not do this one there, right? I just consider x equal to half gt square. I'll retain it like this itself. I'll retain it like this itself. I don't want to go to the second step. I'll go by the same method what we have done earlier. Okay, and then h minus x. Now you threw the particle from here. It traveled a distance of h minus x. So h minus x is equal to ut plus half at square once again. There also I applied the same formula. Here also I am applying the same formula. Okay. So h minus x, the distance covered over here. What is u? U is nothing but root 2gh. This is v. Okay. What is v? V is nothing but initial velocity. So therefore, maybe if you want, I can consider half mu square itself. Half mu square. If it is confusing, I can write like this. Half mu square and u square equal to 2gh, and u should be equal to root 2gh. So I'll write this as root 2gh into t minus, and what do we get here? We get a plus half, and what is a? A is nothing but minus g into t square. What is t square? T square. I'll write like this over here, t square over here. Thus, what do I get here? I can now write this as root of 2gh into t minus half gt square. Now on the left hand side, if you see, this is h minus, what is the value of x? Half gt square. I'll substitute here. So how do I get this? I get it from here. I get it from here, right? I took this value, substituted here, I got this. If you refer to my previous problem and then come back to it, you will see the same working once again. Okay, no difference at all. So now what I do is I'll cancel these two, and then I get h is equal to square root of 2gh into t. Sorry, this t is outside. This t is outside. Or I can now write, let me square this. So I get h square is equal to 2gh into t square. Sorry, into t square, yeah. So this h and this h goes away. In other words, t square should now be equal to, am I doing rightly? Let me check it out once again. Ut, yeah, that's right, that's right. T square should now be equal to h by 2g. H by 2g, right? If I want to check it, how do I check it? Now, see, in an easy shortcut, I'll let you know. H is measured in meters, okay? And 2g, g is measured in what? Meter per second square. So this meter goes away, a second square comes over here. The unit of time square is also second square. So I'm right. Okay. So these are some of the shortcuts you should know. Okay. So because, we start from the problem and finally if we end incorrectly, it'll be a problem for us. So you may not get to know over it. So we do it like this. Now we have got an expression for t square in terms of h by 2g. Now what do I need? I need x by h minus x. Okay. Now what we do is, sorry, I don't have much of space. Let me just a minute. Let me add one more slide so that, what did I do? Wait, I've added one more slide, and now let us do it. All right. Okay. So now, so what was the question here? I need some space to work it out. So I have x divided by h minus x will now be, what is the value of x? Half gt squared. If you are writing it in your notebook, you can easily understand this. H minus half gt squared, which should now be equal to half g into, what's the value of t squared? See, if you look at this t squared, I've got the value of h by 2g. Let me substitute this into h by 2g divided by h minus half g into h by 2g. So when we do it, what do I get here? This g goes away. I get h by 4 here, h by 4. And what do I get here? This will be h minus this g, and this g goes away. So I get this as h by 4, which should now be equal to h by 4 minus 3h by 4, which should now be equal to, how much is it? 1/3, right? X by h by minus x is equal to 1/3. Just a moment. Sorry, I was away from my seat. Okay, so x by h minus x will be equal to 1/3. So what did we understand here? We understood that when you have a building and you dropped a ball from here, you dropped another ball, you threw a ball from here in such a way that this energy was equal to this energy, then this ball would have traveled a distance of h by 3, and this ball would have traveled a distance of 2h by 3. Thus the answer is now, sorry, it is not 2 by, I'm sorry, h by 4, h by 4, and this would have traveled a distance of 3h by 4. Okay. So if, for example, here, this is 300 meters. This would have traveled a distance of 300 divided by 4. And this would have traveled a distance of 3 into 300 divided by 4. How much will this be? This would be 75 meters. And this would be 75 to 25 meters. 225 meters. Okay. I hope you understood this problem as how to solve. If you still have any doubts, you can either refer back to my previous video as how did we do it, or you can also write back to me. So my email ID is here, rathankar@gmail.com, or you can also WhatsApp me, okay, this particular problem, about this problem. In this number, I will definitely be able to help you out. Thank you, friends, for watching this video until the end. And if you like, do share and subscribe to my channel for more updates. Thank you.